Good morning, everyone, and welcome to our webinar this morning, Status of Evolving Carbon and Biofuel Regulations, a Global Bioenergy Policy Roundtable. My name is Karen Righthand. I am the Director of Marketing at SCS Global Services, and I'm happy to present today's webinar. I'd like to introduce Neil Mendenhall, our Director of Service Development, who is today standing in for Matthew Rudolph, and he'll tell you why. Thank you very much.
Welcome, everyone. Like Karen said, my name is Neil Mendenhall. I'm the Director of Service Development here at SCS Global Services. I am taking over for Matthew Rudolph, whose wife went into labor earlier than expected, so he is unable to join us today. I was managing our biofuels and bioproducts division here at SCS for a couple of years before we brought Matt on, and we still have our three experts on the line, so there shouldn't be any issues with Matt not being available. First, I wanted to go over quickly before I introduce our panelists who SCS Services is. SCS stands for Scientific Certification Systems. We, in the last couple of years, changed our name to SCS Global Services. We provide services mostly in the certification area, and it spans a number of different industries: forestry, climate. We do life cycle analyses. We do food and agriculture, manufactured products, food testing, and responsible sourcing. Specifically about our biofuel and bio-based products program, we offer a number of services that you can see there at the top. The first being the Roundtable on Sustainable Biomaterials, RSB. We also offer RSPO, which is the Roundtable on Sustainable Palm Oil. That program is for both food and for biofuels. We also have Bonsucro, which is known as the Better Sugarcane Initiative. It's for specifically sugarcane and their derivatives, which include sugarcane ethanol. And then the International Standard for Carbon Certification, ISCC, which is well known in Europe for biofuels. The feedstocks that our clients are using are the common commodity crops used for biofuels, so sugarcane, corn, palm oil, coconut is a commodity crop, but not typical for biofuels. We also have some novel crops for the biofuel sector. We have camelina, jatropha, energy tobacco, carinata, and gliricidia, which is a tree species that can be used for biomass. We also have waste and residues, used cooking oil, tallow, fatty acids. The products that our clients are producing, our certified clients are producing, are raw refined sugar, molasses, palm oil, and their derivatives. The biofuel specific products are renewable diesel, hydrogenated vegetable oil, biojet, biodiesel, ethanol, and renewable naphtha. We also certify bioproducts, so you can think of bioplastics and biochemicals, and we have a couple of clients doing that as well. Our company is headquartered in Emeryville, California, which is near San Francisco, but we have a number of offices and affiliates that do work for us around the world. To the left there is a list of all of those offices and affiliates, and to the right is the certified entities that we have specifically in the biofuels and biofuel products, which is still a smaller program for us. But as you can see, it's really spread throughout the world. I'm going to stay pretty high level on the three different regulations that our experts are going to go over in more detail. But just to present a broad overview, I have three quick slides. The first being the US Renewable Fuel Standard, so RFS2. This is a volumetric program with greenhouse gas and land use requirements. Volumetric meaning that there are specific requirements on volumes of biofuels that increase annually. It's to go to 36 billion gallons by 2022. Obligated parties, so oil companies, must hold renewable identification number credits, so that's what a RIN stands for, at the end of each year. There are 4 nested categories with different GHG requirements. So these are the different RIN classes. There's a 20% reduction, a 50% reduction, and 60% reduction RIN. And then there's a cellulosic category, which has not grown as quickly as anticipated. And things like biogas and advanced biofuels are kind of filling the gap. Land use change requirements are also as a part of this regulation, and GHG reductions include indirect land use change. Next, we have the EU Renewable Energy Directive and RED II. These are renewable energy targets for European member states. These are to increase renewable energy targets to 10%, EU binding target by 2020. There are land use change and GHG verification that is essentially outsourced to certification schemes. So what I presented before, things like Bonsucro and ISCC are some of the EU approved certification schemes that validate the greenhouse gas reduction of biofuels. There's a 35% GHG threshold that is to increase to 50 and 60% for existing and new facilities in January 2018. And the European Commission is drafting the RED II and extending renewable energy targets to 2030 and limiting certain biofuel feedstocks. And lastly, we have the regulation that's here near our headquarters in California. It's the low carbon fuel standard. This is a carbon reduction program specifically for transportation fuels. Obligated parties are required to lower the carbon intensity of their entire fuel mix sold in the California market. The state is collaborating with other jurisdictions, so the state of Oregon and the province of British Columbia, Canada. Carbon reduction requirements get increasingly stringent each year, towards a 10% reduction in 2020. The Air Resources Board is developing reduction targets to 2030 for transport fuels as a part of Senate Bill 32. They are now in the process of implementing third-party verification for greenhouse gas input data. So that's an area that to pay attention to as well. And they're adding biojet. Next, I'd like to present our expert here that's going to be going over the EU regulations. His name is Rob Verhout. Is the consultant to the EU Regulatory Affairs, and I'll let him introduce himself and background before he goes on.
Hey, just briefly, Rob, before you get started, this is Karen. I forgot to mention that this presentation will be recorded and it will be emailed out to all of the attendees and those that are registered. And also, I'd like to point out the question box in your deck. Please type questions that come up during the presentation into the box, and we will take questions at the end of the presentations. Thank you. Sorry to interrupt.
Yeah, thank you, Karen, for this update, and thank you, Neil, for the introduction. As Neil said, my name is Rob Verhout. I'm a consultant on EU regulatory affairs, and more particular bioenergy. I've been about 15 years advising the European industry on biofuels policy. The last position was Secretary General of ePure. Next slide, Neil, please. Okay, yes. So I'm going to talk about what the EU is doing about reducing carbon emissions in transport, mainly by using renewable energy in transport. And I will address, first of all, the drivers and the targets for the energy and climate policy in the EU. Then I will briefly look at the regulatory framework in force, then go over to RED 2 in the making, and finally discuss some sensitivities and timing about this bill on the table. Next slide, please. So this slide shows you what the greenhouse gas emission trend is in the EU. And you can see with the blue line that we are indeed reducing our emissions substantially. However, with the business as usual scenario, it's the dotted red line, you will see that we are not getting where we should end in 2050, which is the blue dotted line. So action is needed. And at the next slide, you will see that the EU has changed tactics by adopting in October 2014 new targets for 2030. So the first line shows you the present targets in force for 2020, which are targets on greenhouse gas emission savings, renewable energy, and energy efficiency. And the second line shows you what these targets will be by 2030. So important to note is that no longer these targets will be binding for member states. They will be binding for the EU as a whole. However, member states need to achieve certain savings on greenhouse gases, and they are now discussing between each other how to reduce those targets or how to reduce the emission per member state. The next slide will show you that actually in transport, we are not doing very well. It's the only sector where we have more emissions. And you would expect that the member states would continue to have a binding target for renewable energy in transport. However, that's not the case. In the future, by 2030, all the member states need to do their best to achieve renewable energy in all sectors, whether it's transport or heating and cooling, of 27%. Now, let's look at the legislation in force. Next slide, please. We have a couple of directives and one regulation that is, let's say, setting the scene for renewable energy and reducing carbon emissions in transport. The first one is the RED 1. It's been adopted in 2009, and it sets a number of targets, and already mentioned by Neil, and also sustainability criteria to which you need to comply with, otherwise your biofuel cannot be used for achieving the targets. The target is set at 10% renewable energy in transport by 2020 in terms of energy. It's volumetric. Then we have the Fuel Quality Directive, that is basically a legislation that determines environmental standards on fuels, and it sets an obligation on fuel suppliers of reducing greenhouse gas emissions over the entire life cycle by number of tons in 2020. Then we have the so-called ILUC Directive, which has been adopted in 2015, that was basically amending the RED 1 and the Fuel Quality Directive. The most important elements of this directive are, first of all, that conventional biofuels are being kept limited to 7%, and also advanced biofuels of 0.5% in 2020 is being introduced. Furthermore, we have now also ILUC factors in the legislation, but they will not be used for accounting, only for reporting obligations by the member states. Now, this directive is still being transposed by member states, and so far only one member state, Slovakia, was able to transpose it in time. And then finally, there is a regulation that is reducing emissions from light-duty vehicles, which is being reviewed right now, and in 2 months' time, the Commission will propose a revision of this regulation. So next slide, please. So here again, you see what the difference is between 2020-2030 in terms of the Renewable Energy Directive. So we see that the target goes up. It will be at least 27% renewable energy sources in transport. There will be no national binding targets. It will only be at EU level, and there is no specific target for transport. Next slide, please. So now if we go to the RED II, the new the bill on the table, which was submitted by the Commission November last year, already mentioned that there will be no new binding renewable energy targets for member states, no more specific targets for transport. And then we have a quite important change in the present legislation, that is that conventional biofuels or crop-based biofuels, these are the biofuels made from either sugary, starchy or oil crops, will be further limited in their use to 3.8%. Then we also have more ambitious targets for advanced biofuels. And these advanced biofuels also need to deliver high greenhouse gas emission saving, 70% as of 2021. We calculate all the renewable energy by adding up those for electricity, for heating and cooling, and for transport. Furthermore, the biofuels and the biogas, they need to they can only count towards the renewable energy targets if they are produced sustainably and certified. Nothing is going to change. The sustainability criteria stay as they are, and also the whole certification system stays in place. Then member states can apply an ILUC factor if they want to distinguish between first generation biofuels. If some do better than others, they can bring certain biofuels to zero. Next slide, please. The sustainability criteria will also apply to biomass for energy, which is new. In the past, that was not necessary. Fuel suppliers, and that's really also a difference with the past, they need to fulfill at least a certain share of low emission and renewable fuels by 2030. So the onus is really on fuel suppliers. At least 1.5% in 2021 needs to be achieved and will increase over year. Then only a number of fuels qualify under this low emission and renewable fuels, which is biofuel and biogas from waste materials and residues, renewable fuels of non-biological origin, waste-based biofuels, waste-based fossil fuels, and renewable electricity. And certain of these five fuels are capped in volume. For example, the used cooking oils, and also animal fat and molasses. Next slide, please. So here you see with this pie chart how these low emission and renewable fuels are, let's say, shared amongst each other. What is remarkable in this slide is that if you add up everything, we're still lower than the target that's been set for 2020 now, which is 10%. And on top of that is that we keep actually promoting fossil fuels more than we were promoting alternative fuels. Next slide, please. This list shows you, and it's not exhaustive, but it shows you what feedstocks are allowed to be used for making advanced biofuel. So we distinguish between a Part A and a Part B in the annex in the bill. Part A are, let's say, what some call it the true advanced biofuels from residues and waste. And then you have Part B, it's the type of waste which is limited in volume and which does not really require a kind of new technology to be processed. Next slide, please. This slide shows you, this graph shows you how the various advanced biofuels or low emission fuels are being shared again. And it also shows you how the number is being ramped up over time, where eventually at least 6.8% of those fuels need to be achieved by the fuel suppliers. Next slide. And here you see how food-based or crop-based biofuels will be reduced over time. So it goes from 7% to 3.8%. But again, member states can reduce certain crop-based biofuels quicker by applying an ILUC factor. The ILUC factor is mentioned in the below in the slide. And you see that for oil crops, this is quite a substantial figure. So it would mean that biodiesel would be out of the game immediately. Next slide, please. So the bill is being discussed right now by the European Parliament and also by the member states. There are some sensitivities right now, but it's still too early to tell what really comes out of the decision-making process. But first of all, the European Parliament believes that the 27% renewable energy target is not ambitious enough. They want to have a higher number. Some member states believe that the advanced mandates are too ambitious. So it's raised the question whether the 6.8% is going to stay. One of the leading MEPs that is handling the file wants to introduce a sort of indirect factor or indirect displacement factor for advanced biofuels if you're using raw material that actually should be used for something else. Member states and a number of members of parliaments are really split over reducing conventional biofuels to less than 7%. It's well possible that the 7% will stay in the end, but that member states will be given the freedom to reduce if they want to reduce that number. There is a difference of opinion whether waste-based fossil fuels would belong in the Renewable Energy Directive, and most likely these kind of fuels will be kicked out. And then there is a wish by some to replace the Annex 9 by a definition instead of just listing all the feedstock. And some say, well, we should actually merge Part A and Part B instead of having these kinds of separate lists. Next slide, please. So what's the timetable? The European Parliament is now reflecting on 3,000 amendments that have been submitted for votes. These votes will take place in the next couple of months. Most likely we will have an opinion of the Parliament by the end of this year or early 2018. Then the Council will come with its common position most likely mid-2018. And depending on how big the gap is between what the Parliament wants and the Council wants, it might go quicker or it may take some more time. But most likely we will have a new legislation by the end of 2018. Then the new Renewable Energy Directive will take effect 1st of January 2021, and there will be a review halfway 2025. And that will conclude my presentation.
All right, thank you, Rob. And now, just as a reminder, we are going to reserve questions to the end, so please type your questions into the question box, and I will distribute those to the organizers at the end so they can answer them. Next up, we'll be discussing Shashi Menon, who is the CEO of Eco Engineers. We'll be going over the renewable fuel standard here in the US.
Thanks, Neil. Thanks, Karen. Can you confirm that you can hear me okay?
Yes, we can hear you fine.
Yeah, thanks, Neil. So I'm Shashi Menon. I am the Chief Executive Officer of Eco Engineers. And if you can please go to the next slide. Eco Engineers. So I lead a team of engineers, regulatory specialists, and compliance specialists to help biofuel producers and other stakeholders in the supply chain navigate the complexities of the clean energy economy in the US, Canada, and the European Union. So we are based in Des Moines, Iowa, and over the years, we've built up some deep expertise in the RFS, and that's what I'm going to share with you today. Next slide, please. So at EcoEngineers, we work with over 50 producers who are in our compliance program for RINs, and RINs is the currency of the RFS. And as a result of that, we manage over 1.7 billion gallons of biofuel capacity, spanning a wide variety of fuel types, from ethanol and biodiesel to biogas, renewable diesel, and other more new and emerging technologies. We've been inside over 150 biofuel plants in over 20 countries, and we've prepared and submitted over 60 low carbon fuel standards pathway petitions by modeling them in the GREET model. And we have a transaction platform that our clients use to transact their RINs, and that transaction platform saw about 3.6 billion RIN transactions in 2016. That's about 10 million transactions per day. So we see a wide range of activities in the marketplace and as a result of that. And finally, we were one of the first US EPA recognized RIN quality assurance program provider. So we put a stamp of quality on RINs, and we get to see how the industry is operating from a variety of different perspectives. So that's sort of our resume and what prepares us to offer some guidance on how the RFS is functioning right now. Next slide, please. So I've divided my presentation into two parts. First part, I have a few slides on a high-level RFS 101, and that talks about the RVOs, decodes, life cycles, and the RIN life cycle, and how they enter the market. And the second half, I'm going to talk a little bit about market drivers that affect RIN values. Next slide, please. So the RFS has broadly divided the biofuel sector into three buckets. And on the far left, there is the renewable fuels, which consist of corn, starch, ethanol, and other grandfathered biofuel facilities. These facilities can must meet a minimum of 20% greenhouse gas reduction relative to the baseline set. Or if you're grandfathered, actually, you don't even have to meet that 20%. You could be less than that and still generate what is called a D6 RIN. And in the RIN world, a lot of the terminology centers around D codes. And so a D6 RIN stands for the basic renewable fuel that must meet a 20% or lower greenhouse gas reduction relative to the baseline. The next bucket of biofuels is the advanced biofuel category that includes biodiesel. That includes biodiesel, renewable diesel, sugarcane ethanol, and possibly ethanol from some other feedstocks such as sorghum, and some pathways that the EPA has approved for biogas as well. They all fit into this advanced biofuel category. And these D codes are D4 and D5. And these fuels pathways must meet a 50% greenhouse gas reduction relative to the baseline. And finally, on the far right, we have cellulosic fuels, which are D3 and D7 RINs. And these fuel types must meet a 60% greenhouse gas reduction. And these includes cellulosic ethanol from Kernel Fiber, cellulosic diesel, and renewable CNG and LNG, compressed natural gas, and liquefied natural gas from biogas, and renewable electricity from biogas as well. So as you can see, the cellulosic fuel category is really a subset of the advanced biofuel category, because if you can meet a 60% reduction, you're also meeting a 50% reduction. And similarly, the advanced biofuel category is a subset of the renewable fuel category, because if you're meeting a 50% reduction, you're obviously meeting a 20% reduction. So in that sense, these fuel types and mandates are nested. You can use a cellulosic fuel to meet your compliance with both the advanced biofuel and renewable fuel categories, and you can use an advanced biofuel to meet both your advanced biofuel.
Shashi, I think we might have lost you. I apologize. Let's see if we can get Shashi back on.
Hello?
Okay, we can hear you now.
Yeah, can you hear me now?
Yes, yes.
I don't know what happened there. My phone just got dropped.
Okay, we can hear you now.
Yeah, can you, I just switched over to my computer phones. I think I can hear you now.
Okay, great. You can keep going.
Yeah,
Thanks.
thank you. Next slide, please. So the RFS functions around the annual volumetric mandates that the EPA puts out, and the EPA comes out and says how many gallons of biofuels need to be mixed with the blended with the petroleum fuels stream each year. And so I got the 2017 and 2018 RVOs boxed in the box there. And you can see, let's say, for example, in 2018, the RVO is 19.24 billion gallons total, of which 15 billion gallons must come from the renewable fuel D6 category, and the remaining 4.24 billion gallons must come from the advanced biofuel category. The advanced biofuel category is further divided into biomass-based diesel category, which you must meet a 2.1 billion gallon requirement there, and a cellulosic fuel category of 0.238 billion or 238 million that must come from cellulosic fuels. The difference between the 4.24 advanced biofuel category and the sum of biomass-based diesel and cellulosic, that difference is an undifferentiated advanced biofuel category that can be met with more biodiesel, more renewable diesel, or with sugarcane ethanol and other advanced fuels that are currently available in the marketplace. Now, from looking at this, it would appear that the EPA has actually dropped the total renewable fuel requirement from 19.28 to 19.24 from 2017 to 2018, and that is true. The way the EPA works is that they propose an annual rulemaking, and then they take comments from the public, and they finalize it by November of this year. So we are right now in the middle of that process. The window to submit comments is closed, and the EPA is probably busy reviewing all that, and they'll publish the final rulemaking by November of this year. So we expect the final rulemaking to be somewhere along this category. It'll probably be 19.24 or maybe a little higher than 19.24, because the general industry backlash was to say it is too low, and the reduction, although very minor, is still a symbolic gesture, and symbolically the EPA is sending a somewhat of a negative message by reducing the total volume mandate from 19.28 to 19.24. However, from a practical perspective, we are not seeing a huge impact of this on RIN prices, because even at this level of 19.24, and the 15 billion gallon D6 mandate, it's definitely creating a pressure on both the ethanol markets and biodiesel markets to produce sufficient RINs to even comply with this mandate. And I'll talk a little bit more about that in a further slide. The big, can you just step back to the previous slide for a minute? The big issue here is for what's going to happen between 2019 and 2022. Statutorily, the RFS volumes are set at 28, 30, 33, and 36 billion gallons, with the bulk of that coming from advanced biofuels categories of 13, 15, 18, and 21. Where we are at today is quite far from being at 13 billion gallons or 21 billion gallons. So the real question is, what is going to be the advanced biofuel category mandate between 2019 and 2022? And how is the EPA going to give sufficient assurance to the industry and give some stability to the industry so they can use it to go to the bank and finance these projects? Next slide, please. So can you just click on it one more time, Neil? So as you can see, this is divided into two parts. The bottom part is the physical pathway, and I'm just using ethanol as an example. And if you are a producer within the US, you don't have to worry about the USA line. But if you're a foreign ethanol producer and or even a domestic one, the first thing that happens is that as the ethanol enters the US marketplace, it is attached to something called a RIN. And at the bottom, the ethanol moves to a blender, and from the blender, it is the blender produces some sort of a transportation fuel, usually E10, but it could be E12, E15, or even E85. And that blended fuel is sent to a gas station, and from the gas station, it is pumped into the fuel tank and it is used in a vehicle. So as soon as the blended fuel is created, the RIN, which only exists in EPA's online databases, and the RIN in that EMTS is separated from the ethanol, and the RIN has its own life. It is transacted in RIN markets. It could change hands multiple times, and ultimately it ends up with an obligated party who is an oil refiner or an oil importer, and who uses it ultimately to meet their renewable volume obligation. Next slide, please. In order to, as a fuel producer, in order to enter this marketplace, you have to determine and demonstrate your pathway to the EPA. And then in order to do that, you must engage with the independent third-party engineer to come and walk through your plant and write a report verifying that your fuel production pathway meets the requirements of the RFS. And the projects must be substantially complete for that to happen before it can be verified and registered. And there must be a fuel certificate of analysis submitted to the EPA, and the EPA review and approval could take anywhere from 3 months to 3 years, depending on the complexity of the application and the pathway. And finally, after all that, once you have the ability to generate RINs, there's ongoing compliance and record-keeping requirements. Next slide, please. One key element of ongoing compliance and record-keeping is the quality assurance program. It's a voluntary audit program for RIN generators. Although it is voluntary, in many cases, the marketplace tends to make it a requirement. In other words, if you want to sell the RIN, you should have a QAP. And that's especially true of newer pathways, newer technologies, and newer fuel types. The auditors, we are an auditor, and we have to maintain our audited status with the EPA and meet all the EPA criteria for independence in order to do the current status and issue current verifications. The benefits of all that is, if I'm an obligated party and I buy a QRIN, then I am actually I receive what's called an affirmative defense. And if in the future that RIN is found to be invalid, then the EPA will waive all civil liabilities against me, although I will still have to replace a RIN. Next slide, please. So I'm going to talk a little bit about market valuations and what are some market drivers that impact RIN values. Next slide. So I touched on this briefly in one of the previous slides when we were talking about RVOs. The U.S. ethanol consumption has a ceiling that is being hit, and that is about 10% of the gasoline consumption. In other words, if you go to a gas pump and buy gasoline, it's usually at a 10% blend level. 10% of that is ethanol, and it's been difficult to break through that 10% blend wall due to a variety of reasons related to car manufacturers' warranties, gas station warranties, tank and piping warranties. And there's also a variety of public perception issues. So all these elements have conspired together to hold ethanol blending to a 10% level, and that's caused some impact on the ability to generate D6 RINs. So what's really happened is that there's a 15 billion gallon mandate for ethanol or D6 RINs right now. And it's unlikely that in 2017 or in 2018, the US will blend 15 billion gallons of ethanol into fuel. It'll more likely be around 14.4 billion in 2018. So it's about a 500, 600 million gallon shortfall that results from that circumstances. And this shortfall is going to have to be met by dipping into and borrowing from the advanced biofuel category. And the biggest advanced biofuel category that is commercially available to fill that gap is really biodiesel. Next slide, please. So what happens is that the price of the RIN values are led by D6 demand, but the key drivers of what's really the marginal cost of fulfilling the D6 demand is the D4 RIN. Because once the D6 RINs are not available, you have to go in and purchase a D4 RIN in order to meet your D6 mandate. And the biodiesel RIN or the D4 RIN is dependent on a variety of issues, from feedstock prices, diesel prices, dollar blenders credit, etc. And this graph sort of shows you how stark that was. Till about 2013, the D6 mandates were below the blend wall limit, and they were practically worth pennies. And as soon as it became clear that the D6 mandate was going to be above the blend wall, the prices shot up. And since then, it has converged very clearly with the D4 prices. Next slide, please. So these are some historical RIN values, and you can again see how D4, 5, and 6 have converged at the bottom, roughly in line. And the only times when D6s have decoupled from D4 and D5 prices is when there's been perception in the industry that the D6 mandate is going to be below the blend wall, or the EPA is going to do something to scale back the ethanol blending requirements. But so far, so you can see from about November 2016, after the current administration took office, to about now, there's been mixed feelings about how the EPA and the current administration will treat the ethanol mandate, and so people were discounting D6 prices throughout that time. But recently, we are seeing that, especially since they come up with a 15 billion gallon proposal for D6s for 2018, it's unlikely that the administration is going to do anything to scale back the ethanol mandate, and we're seeing the prices converging quite steadily. The top part, and I'm not going to go into this too deeply in this talk, but the top part, the D3 price range, can range from a floor of a D5, D4 level, and to a ceiling, which gives you a $2 premium above that. And currently, we are seeing the D3 prices trading at the higher level with the $2 premium. Next slide, please. So what affects the pricing of RINs? It's really supply-demand fundamentals and regulatory uncertainty. And if as the advanced biofuel and biomass diesel RVOs are set higher, it's going to create greater demand. The pace of biofuel production versus a mandate. Availability of banked carryover RINs, temporary shifts in supply demand, regulatory uncertainty, and finally, there's perceptions of fraud and political events. So all of these conspire to affect the RIN pricing on a given day. And what we're seeing is that of all these, a lot of this is just market perception, and there's very little fundamentals sometimes that is actually driving the RIN pricing. Next slide, please. For example, this slide kind of shows you how political events and perceptions of how political events could potentially impact RIN pricing has affected RIN pricing. We've listed all the events there, and we've shown there's a direct one-to-one correlation between a political event and the impact on RIN prices, starting with Donald Trump's election as the president of the country, all the way to a U.S. appeals court striking down the 2016 RVO rules against the EPA. So each of these events creates specific impact on RIN prices because there's a perception on how that's going to impact supply and demand. Next slide, please. So uncertainty is kind of the new certainty these days. Over 220,000 comments were received on the 2018 RVOs just recently, and just looking into the crystal ball, it's really difficult to know what lies in the future. The real question is, what is going to be the RVOs 2018 to 2022? How to incentivize second-generation fuels? What methodology should the EPA use for calculating annual RVOs? Will starch ethanol push through the blend wall? These are all real immediate questions that could have an impact on RIN prices and the RFS. Then there's the whole issue of imports versus domestic production. There's definitely a protectionist trend right now with the Commerce Department potentially filing some tariffs against Indonesian and Malaysian biodiesel. Indonesian and Argentinian biodiesel, and there's a movement to maybe make the blender's credit a producer's credit for biodiesel, which will also disincentivize imports. And then there's a question of, will the point of obligation change? There is something called the regs rules that's been outstanding for a while. And finally, the overall impact of how what is the political impact of an administration that does not champion climate change? All this is kind of unknowns, and it will determine how the RFS is going to pan out over the next 5 years. Next slide, please. One bright spot in all this is that there are new cellulosic pathways. This is sort of the latest trend and the big push right now. This D3 ethanol from Kernel Fiber and this D3 CNG LNG from biogas from wastewater treatment plants, landfills, and manure digester biogas. Next slide, please. Good advantage of Kernel Fiber is that there is no indirect land use change impact. There's no corn farming and transportation burden, and the carbon intensity is in the range of 10 to 40 grams of CO2 per megajoule, which is a huge improvement from conventional ethanol. And so we're seeing a lot of ethanol plants enter the space and implement technologies to extract ethanol from the kernel fiber. Next slide, please. And finally, we're seeing the same thing with renewable natural gas or biogas, potential value of 1 million BTUs of pipeline quality biogas that's used for transportation in California is about $30+. That's like 10 times the value of the gas itself. And the majority of those values are coming from like 90% of the values will be coming from federal credits and California credits from the low carbon fuel standards, which Graham is going to talk about next. So I think that's all I have for today. If you have any further questions, yeah, feel free to enter your questions into your chat box, and I'll be happy to take them at the end of the presentation. Thank you.
Thank you for that, Shashi. And yeah, like Shashi just said, or if you just joined in the middle of this presentation, please put your questions in the chat box, and we will get to those at the end of the next presentation. So last but not least, we are going to go over, excuse me, California's low carbon fuel standard and GHG policy trends. And here to present that is Graham Noyes. He's the Executive Director of Low Carbon Fuels Coalition and a Managing Attorney at Noyes Law Corporation.
Great,
Graham?
Thanks very much, Neil. This is Graham Noyes speaking to you from the Sierra foothills this morning. I guess we're moving east to west, and I will be wrapping up with an overview of the low carbon fuel standard. Next slide, please. So in terms of my vantage point coming into this, I really wear two hats in this space. One as a regulatory attorney focusing on fuel and carbon issues. So I do regulatory analysis and compliance counseling for clients, advocacy and rulemaking, and one specific example of that in the low carbon fuel standard is I'm representing the alternative jet fuel producers in requesting that ARB add biojet to the low carbon fuel standard. And I also do some work on enforcement defense issues on both the LCFS and the renewable fuel standard that Shashi just covered for us. I also serve as Executive Director for the Low Carbon Fuels Coalition. The mission of the coalition is to defend and expand sound low carbon fuel policies focused on the transportation sector. And we also do significant work in the policy tracking space. Next slide. So the, excuse me, the low carbon, sorry for the delay there. The low carbon fuel standard is basically a program that is designed to reduce the carbon intensity of fuels used in the transportation sector. We'll look at the carbon intensity curve from 2018 through 2020, and then the 2021 through 2030 curve, and the ongoing activity around interpretation and rulemaking. And some of the new policy directions to think about in this sector are greenhouse gas reduction as a proxy for criteria pollutant reductions, and the health and environmental justice issues associated with that. And then longer term, we see some trends on the fuel policy horizon in California, the move to low emission diesel, the electrification of the transportation sector, and a drive for technology neutrality. I think this is in contrast to what Rob laid out for us on the European side in terms of the more of an evolving program that isn't necessarily as specific in terms of feedstock picking, but tries to measure things in a scientific based comparison system. Next slide. So in terms of the overall background of this program, the original foundation was AB 32, the Global Warming Solutions Act of 2006. That established a mandate for California to reduce greenhouse gas emission levels to 1990 levels by 2020. So this is referring to the overall California economy. That was authorized. The specific low carbon fuel standard program was authorized by Governor Schwarzenegger by executive order, and that essentially tasked the Air Resources Board, what folks sometimes refer to as CARB or ARB, with the implementation of LCFS regulations. Next slide. So in terms of how the program judges fuels, it is a carbon emissions perspective, essentially an efficiency perspective. How much carbon pollution is released per unit of energy. And it considers all the carbon pollution, a cradle to grave approach, life cycle assessment, including the feedstock, the facility, the fuel, and transportation, as well as co-products also produced. Next slide. So we've got the current program, the LCS requiring a reduction of 10% from 2010 to 2020. Most of that is backloaded, so the program is decreasing faster year to year. It's not a flat line reduction, but a curve downward. And we have a full range of fuels within the scope of program: CNG, LNG, RNG, electricity, hydrogen, and the regulated parties are petroleum refiners and importers, and they can comply by either producing or buying fuels that generate credits, reduce the CI of their crude oil or their refinery. So there are refinery side compliance mechanisms, and this is a market-based program. Next slide. This slide is worth sort of looking at for a moment to get a handle of it. What is significant here is the bubbles are sort of the volumes of fuel, and you'll see that kind of baby blue, ethanol being the bulk of the volume, but a fairly wide range on CI scores, and those carbon intensity scores are what I referenced there. The overall measurement for each fuel. You'll see electricity. This is actually adjusted for what they call the energy efficiency ratio, or EER, and so electricity benefits from the inherent efficiency of electric vehicles. If it were just the CI of California grid mix electricity, it would actually be right out there by the 100 mark on the CI scale, but you get a multiplier reducer effectively for the efficiency of EVs. You can see bio-CNG, relatively low carbon intensity, renewable diesel, having some renewable diesel relatively high on the scale, but then the bulk of it below 40. And biodiesel at a number of different ranges, and this is really feedstock driven primarily. So your material to the far left there is going to be used cooking oil type material. In the 60 range, most of that's going to be soy, and I'd speculate that the material above 80 is probably perhaps soy from an older facility with less efficiencies, and that 100 may or may, I don't think there's any palm oil that's actually been used and approved as a feedstock, but I'm not sure what that final blue circle is for the biodiesel right around the 100. Next slide, please. So transitioning between these two slides, and everybody, of course, wants to get to the bottom line on these programs. This is kind of a cheat sheet here that ARB has come up with that's quite useful. And for our purposes, the market is closest to $100 a ton. So we'll look at the vertical column with 100 there. And some of the things we just talked about, to start with, first of all, the carbon intensity level of, for instance, ultra low sulfur diesel currently is at about 102, and the 2017 standard is at 98.44. So if you think of the ultra low, that fuel is actually generating a deficit with each gallon sold by the regulated party. The same is true for CARBOB, California gasoline. In the lookup table, that's at 100 CI points, and the standard is at 95. So every gallon sold generating a deficit that needs to be caught up with by blending activities or buying credits. And as we saw with the prominence of ethanol in the last slide, much of that is essentially oxygenate blending. Most of the fuel in California is E10. So what has happened, what the LCFS has done here, has driven the carbon intensity of ethanol that comes into California down. Excuse me. And we're now down about 20%. So your corn ethanol is at about 20% less than the CI number, giving you about 20 CI points, or we look down at that number at about 80, and we see that's about 19 cents per gallon of value. Dropping down to a used cooking oil, your CI score there might be about a 20. So at that $100 value, you're at 89 cents a gallon. And if we went all the way down to a bio CNG, like Shashi was talking about, and specifically anaerobic digestion, that CI score is all the way into the negative. And this doesn't show a negative, but we see a 0 CI score will get you $1.12, and then if you add another 30 points to that, you're at $1.42 for that particular fuel. So wide range of values, custom based depending on the score. Next slide. So that really was the overview on the LCFS. I want to step back now and talk about the Fortified California climate policy. This has been driven heavily by Governor Brown, but there's also tremendous support in the legislature. And Governor Brown in 2015 put forth this executive order establishing this 40% goal for the state below 1990 levels by 2030. In 2016, we saw the first round of legislative activity to extend the greenhouse gas reduction policies. SB 32 bringing the levels 40% below 1990 levels by 2030, so matching up with the executive order by legislative authority. And then we saw the environmental justice and concerned about criteria pollutants and toxic air contaminants sort of expressed by AB 197. In 2017, a lot of concern about a court challenge called the Chamber of Commerce against the cap and trade program. Governor Brown and the legislative leadership pushed very hard to achieve a 2/3 majority approval of the cap and trade portion, which was AB 398. Got that 2/3 majority approval, which insulates the program from the legal challenge, and that was to the extent that the program raises fees. There's a requirement, particularly if it's a tax, that it be approved by 2/3 of the legislature. And so having this 2/3 majority approval basically takes the lawsuit off the table. In addition, we saw AB 617 as one of the companion measures, again focused on environmental justice, toxic air contaminants, criteria pollutants, the other sort of corollary benefits that are linked up in the California policy world with the cap and trade and overall greenhouse gas reducing program. Very important for our purposes. In 398, there was an explicit reference to the low carbon fuel standard, stating that there is no change to the program as a result of the passage of the legislation. Next slide. And I've picked up a couple of these issues already, but expressing them, and these are conversations we had with the legislature when these programs were moving forward. We see the importance of transportation fuels from a GHG inventory perspective, where they're 40% of the carbon pollution in California. Of course, California, a very car-centric state. Transportation fuels delivering 85% of NOx in the state, which, because of our unique air quality challenges here, is a tremendous issue. And 90% of the cancer-causing diesel particulate matter is coming from transportation fuels. So these are things that are also targets in the state. The low carbon fuel standard, one of its real strengths has been it is a market-based program that doesn't require an appropriation, and that's very positive. Next slide. And just a couple of facts here again that we use with the legislature during the extensions, the reductions in greenhouse gas pollutants in the order of 16.6 million metric tons. We've gone beyond that. That was just through 2015, and we're seeing health and societal benefits and the prevention of premature deaths from asthma and exposure to toxic air contaminants. Next slide. Also, tremendous activity. There's been a big challenge to California's emphasis on the clean energy economy. I think it's fair to say that's a national debate, but California's economy is really thriving, particularly in the venture capital sector, and the state has much of the new venture activity and clean economy capital is being invested here. Next slide. And I'm going to wrap up quickly here because we do want to leave time for questions. This is an overarching scenario that shows the reductions require across the whole economy as we move for this very aggressive 40% reduction by 2030. Next slide. And this is just an example of how ARB provides workshop opportunities and public comment opportunities in the policy development sector. Next slide. And so turn into the LCFS rulemaking we're in now. We actually have workshops ongoing for the rest of this fall. We have basically an upgrading of the program, particularly with a monitoring and verification component comparable to the quality assurance program that Shashi talked about in the RFS. We have proposals to add alternative jet fuel, propane, and military uses as opt-in fuels, lots of tweaks, changes to California GREET. Next slide. We also, looking down the road, see a tremendous interest in renewable diesel, low emission diesel for the state, again, because particularly in the middle and heavy duty sectors, continued reliance on liquid fuels, and to get the kind of NOx reduction that California wants to see, we're going to need lots of renewable diesel, lots of low CI and NOx mitigated biodiesel, biomethane, and other solutions out there. Next slide. Thanks very much for your attention, and I think we're going to turn to questions at this time.
Thanks a lot, Graham. Now we've received a number of questions that have been typed in, and I'll try and get to as many of those as we can in the next 10 minutes or so. And then I'll just say that we'll try and get back to questions we haven't responded, or if you have any questions, here are people's contact information. You can get back, ask those questions directly to them. The first one I have here, it would be directed to you, Rob. Does the EU make a distinction between ground, marine, or air transport?
Basically, the Renewable Energy Directive will apply to ground transport. But in some member states, it's also allowed to, and that really depends on the member states, it's also allowed to use biofuels in shipping and aviation. But it's up to the member states to decide what they want and how they report on that to Brussels.
And here's another one for you, and I know this is a question that a lot of people have, Rob, is why are biofuels like molasses being capped? So.
I read this question as why molasses as a feedstock being used for producing advanced biofuel is being limited. I think the consideration is that most likely there is only a limited volume available. And secondly, molasses is also used as an animal feed. And there are concerns that if you allow too much molasses to be used for biofuel production, you would endanger the availability for molasses as an animal feed.
Okay. Another one here is co-processing addressed by the EU, refining renewable crude in conventional petroleum refineries, for example.
Normally that is not allowed. But also here, sometimes member states are lenient in allowing it. But according to the legislation, the European legislation, it's not allowed.
Here we have a general question that probably applies to all. What is a waste-based fossil fuel?
Yeah, waste-based fossil fuel could, for example, be CO2 you are using as your main feedstock. For example, noise on the line, I don't know why. For example, if you take a process that is being developed by Lancatech, they use CO2. Which is a result of a fossil-based operation. Not always, but sometimes it is.
This is Graham adding to that question. Point to make about the three different programs that Rob laid out. There's very specific limits in the EU around particular feedstocks. When we look at the RFS, we have a renewable biomass requirement that's sort of fundamental to that program. Whereas in California, we have a carbon intensity measurement that doesn't particularly specify the feedstock, but does go out and do an individual analysis of the various components. So what the feedstock carbon intensity looks like from an ILUC perspective, what the transportation looks like. And so you see some very different treatment of something like waste-based materials or some of the different feedstocks depending what program structure you're in.
Okay, we have another question for Shashi specifically. Can you give a novice an idea of what goes into calculating the carbon intensity? And quickly.
Sure. The carbon intensity calculations that we have used to primarily use the California GREET model However, the RFS does not exclusively use a GREET model. They use a GREET model in combination with a variety of other models, such as FAPRI, to come up with a comprehensive carbon intensity or footprint for biofuels. The EPA does all their carbon modeling themselves, and then they allocate those feedstocks and the fuel, the entire pathway, to one of those buckets of advanced biofuels, cellulosic fuels, or renewable fuel, based on the modeling they do. And if you want to challenge that, then you're free to submit a petition. But fundamentally, they do all their modeling. Whereas in other programs such as California, there's a lot more latitude on the part of applicants to do their own modeling. So for us, we start off with the California GREET model or the GH Genius or BioGrace, depending on the regulation. And then if needed, we can enhance that to, depending on if the EPA wants us to do something else, we can always have a discussion with them on that.
Okay, there's a question that a number of people asked if the presentation will be available and the recording will be available. It will be. It will be sent out to everybody who registered with a link, I believe. Also, another question: what is the renewable natural gas? What is a renewable natural gas predominantly produced from? That could go to any one of you guys, I assume.
Right. So this is Shashi, and what we see is there are three main sources for renewable natural gas. One is landfill gas. The other is biogas from wastewater treatment plants that come from anaerobic digestion of biosolids, and or other types of industrial and household waste. And finally, there are agricultural digesters that process manure and possibly even other crop residues. And all of these digesters can potentially take waste from industrial operations as well and process them. So if it comes from cellulosic sources, such as manure or municipal biosolids or landfill gas, then under the our EPA, you're eligible for D3 cellulosic RINs. If it comes from food waste, such as if it comes from fats, oils, greases, or industrial food waste, or separated food waste from consumer food consumption, then it's eligible under the RFS for advanced biofuel D5 RIN. Now, as Graham alluded to, under the LCFS, these pathways can take a whole variety of carbon intensities, ranging from just compressed natural gas, fossil natural gas, has a carbon intensity of what, 60 or 70, and then landfill gas and small wastewater treatment plant maybe anywhere from 10 to 30. And then at the other end, you have certain manure digesters from dairy manure that are eligible for carbon intensity of minus 280. So, so depending on what your sources are, your value in the marketplace can vary quite a bit, and depending on which state you ultimately sell that fuel in.
Neil, for once, Europe is quite simple in this respect. We only have biogas, and that means that it is a gaseous fuel produced from biomass.
All right, thanks, Rob. Maybe one of you quickly go over the difference between renewable diesel versus biodiesel.
This is Graham. I'll field that. So biodiesel is been around in the market for a longer time, really, than renewable diesel. It's produced through transesterification and is, I'd say, in some respects, a simpler process. But what is very comparable between biodiesel and renewable diesel is they typically use many of the same feedstocks. So the fats and oils, used cooking oil, also the virgin oils are available. Renewable diesel looks quite a bit more like a refinery from a processing perspective, and the fuel that's produced typically is going to meet the diesel spec D975, whereas biodiesel has an alternative specification that's not conventional diesel. So depending on where you are, there's going to be a different regulatory requirements around biodiesel and renewable diesel, and there are other issues around infrastructure and so forth, because the fuels are significantly different in characteristics.
All right.
Yes, maybe I could add on, Neil, to what Graham said. Europe, we don't have a definition of what renewable diesel is, but generally it's understood as a more sophisticated diesel or processing, as Graham told, than biodiesel. But it's also a diesel that we call a drop-in. You can use it at a quite high percentage in diesel, whereas biodiesel is only allowed up to 7%. A renewable diesel could well be blended up to a level of 35%.
Thank you. So we are out of time. My understanding is this was to go for an hour and 15 minutes. We are 1 minute over. There are a number of other questions here that we can get back to you. If you feel like your questions have not been answered, you can, the contact information of each of the participants or panelists today is on the screen. Karen, did you have anything else in closing?
No, we'll be sending out a follow-up email tomorrow, and we will include the contact information then. Thank you, everyone, for listening. We look forward to following up with you shortly.